Good evening, Andarki. Welcome to Physics Masterji class. Guys, there are roughly 37 days to your exam date. So I would like to start a revision series in which each and every lesson will be explained in two parts. Part 1 is a one-shot video on a theory and a part 2 is important PYQs. So important PYQs less than 30 will be delivered only in a one session. Ledu more than 30 unnai, 40 unnai, 50 unnai ante I will just make it into two parts and I will revise it. So already ray optics video post chesanu. In the ray optics I only explained this refraction part. Reflection explain cheyaledu, but I will do it soon, right? So ee roju class lo let's talk about refraction PYQs. So there are roughly 27 PYQs on a topic 2 that involves this refraction on a plane surface. So tomorrow I will explain this lenses part, right? So ikkada first question vachepatiki here the first question is on question number 27. Question number 26 is easy question number 27. So question number 27 is all about a glass lab. So నేను చెప్పిన క్లాస్లో హరి దగ్గర నేను గ్లాస్ ల్యాబ్ ఎక్స్ప్లెయిన్ చేయలేదు. సో ఫస్ట్ ఐ విల్ ఎక్స్ప్లెయిన్ ద గ్లాస్ ల్యాబ్ కాన్సెప్ట్, దెన్ ఐ విల్ గో త్రూ ద క్వశ్చన్, రైట్? క్లియర్? ఫస్ట్ ఐ విల్ ఎక్స్ప్లెయిన్ ద గ్లాస్ ల్యాబ్ కాన్సెప్ట్, దెన్ ఐ విల్ ఎక్స్ప్లెయిన్ దట్ క్వశ్చన్. Let's say there is a glass slab. So, normal line in the ray incident here on the glass slab, and that will refract close to the normal line, right? So in case rare medium nunchi density medium loki vaste light close to normal move ayedi. So ikkada kuda normal draw chestunna, and again now the light is moving from denser to rarer. So what happens? So normal ki duranga poyedi, right? So normal ki duranga poyedi. So this is called as incident ray and this is called as a emergent ray, right? Now if I just extend this incident ray, ee incident ray ni extend cheste, that goes right like this. Incident ray ni expand చేస్తే that goes right like this. సో ఇప్పుడు దిస్ ఈజ్ కాల్డ్ యాజ్ ఎమర్జెంట్ రే అండ్ దీని ఏమంటాం ఇన్సిడెంట్ రే. ఈ రెండింటి మధ్యలో డిస్టెన్స్ ఏమంటాం అంటే ఈ పర్పెండిక్యులర్ డిస్టెన్స్ ఉంది కదా, ఈ పర్పెండిక్యులర్ డిస్టెన్స్ ఈజ్ కాల్డ్ యాజ్ lateral shift అంటాం, రైట్? సో దట్ ఈస్ దిస్ క్వశ్చన్ ఇస్ ఆన్ ద lateral shift. ఈ మధ్యలో ఉన్న పర్పెండిక్యులర్ డిస్టెన్స్ ఏమంటాం అంటే lateral shift అంటాం. ఇది వచ్చేప్పటికి lateral shift. నౌ వీ హ్యావ్ టు క్యాలిక్యులేట్ దట్ lateral shift ఎంత అని, రైట్? సో దట్ ఈస్ ద క్వశ్చన్. So now let's say delta x, and you know this angle is called as incident angle I, and you know this angle is called as the angle of refraction r, and you could see this total angle is how much? I, and therefore e angle enta ante I minus r, right? So one second. And let's say the thickness of this glass slab is T. The thickness of this glass slab is T. So from this right angle triangle, from this right angle triangle I can write it as, so sin I minus r equal to sin I minus r is equal to what? Opposite side is delta x by hypotenuse. So let's say ఈ లెంత్ వచ్చేప్పటికి అందక L అనుకో, that hypotenuse is let's say L. Therefore I could say this delta x is L into sin I minus r, right? So again if I extended this one like this, so that is nothing but thickness. Again from this one, from this right angle triangle I can write it as a cos r. So cos r is, I could say cos r, so cos r equal to, again this is cos r can be written as adjacent side by hypotenuse. So adjacent side is how much? Thickness of the glass slab T, and hypotenuse is how much? L. Therefore this L can be written as L is equal to T by cos r. L equal to T by cos r. If I substitute here, I could get this delta x is equal to, so L can be written as a T by cos r, into this can be written as sin I minus r, sin I minus r. Therefore this delta x is, so delta x equal to how much is it, t of sin I minus r, t sin I minus r by cos r. So this is a lateral shift formula. That was the lateral shift formula, right? Clear? So check it once. That was the lateral shift formula. That was the lateral shift formula. Now look at the problem. The problem is this one. So that was the problem. A ray of light is incident on a glass slab of a thickness, of a thickness 4√3 centimeter and refractive index is √2. The angle of incidence is equal to the critical angle for the glass slab with the air. The lateral displacement of a ray after passing through the glass slab is. So he is saying that this angle of incidence is equal to the critical angle. Since the critical angle formula is explained in a previous class, since the critical angle formula is, what is the critical angle formula? We can write as a sin C is equal to 1 by n, where that 1 is refractive index of air and n is refractive index of a denser medium. So here this particular glass slab is having a refractive index as a √2. Therefore I could say the sin C equal to 1 by √2. Sin C is equal to 1 by √2. Therefore the C is equal to how much is it? 45 degrees. The C is equal to 45 degrees, that is equal to this critical angle is also nothing but incident angle here. Therefore that is also nothing but a I. Clear? So that is sin C is equal to 1 by n. So even that formula need to be keep in the mind. So sin C is equal to 1 by n. Therefore we get this incident angle is equal to y. So again if I apply this Snell's law here, a particular point Snell's law apply yes, I will get this refraction angle. Therefore I can directly substitute in the formula, right? So what is the formula here? That was the formula. Now in order to solve this problem, I want to find out this r. Therefore r equal to, in order to find out r, I have to use the Snell's law, right? So actually I am just unfamiliar to this app, so therefore taking a much time. Maybe problem just sound alvaatayidemo, just excuse me for this, right? So therefore I can write as Snell's law, n1 sin I is equal to n2 sin r. n1 sin I is equal to n2 sin r. I want to find out this r in order to solve the problem. Therefore what is the n1? It is the air, so 1. And what is the sin I? Sin I is 45, so sin 45 is 1 by √2 will be equal to n2. n2 is again √2 for the glass slab. Sin r, we don't know this sin r. Therefore you could clearly see here that sin r will be 1 by 2. Therefore r is equal to 30 degrees. So even the Snell's law is also important here, right? The Snell's law also important here, therefore keep it is also important. So r is equal to 30 degrees. Now what I have to do? I have to just substitute all the values here. I know the thickness here. Thickness is how much? 4√3. The thickness is a 4√3 and I know I is how much? 45 and I know r is nothing but 30 degrees. So therefore if I just substitute, right? So substituting the values, therefore delta x equal to, this t is 4√3 and this sin I minus r, I is 45 and 30, therefore I can write as sin 15 by cos r, cos 30 √3 by 2. So the 2 will here, √3 is here, so this one get cancelled, that will be equal to 18 to sin 15. Sin 15 can be written as a 0.25. Therefore you might get the answer as a 2 centimeter, right? That was the answer for this one. And ఈ గ్లాస్ ల్యాబ్లో lateral shift కనుక్కోవాలంటే this is the formula, delta x is equal to t of sin I minus r by cos r. ఈ రెండు ఒకదానికొకటి పర్పెండిక్యులర్గా ఉంటాయి. దిస్ ఎమర్జెంట్ రే అండ్ యాజ్ వెల్ యాజ్ ఇన్సిడెంట్ రే రెండు పర్పెండిక్యులర్ ఉంటాయి కాబట్టి డీవియేషన్ ఎంత అంటే డీవియేషన్ ఈజ్ ఈక్వల్ టు 0. సమ్ టైమ్స్ దట్ మైట్ బి కెన్ బి అది కూడా అడగవచ్చు. సో కాబట్టి డెల్టా ఈక్వల్ టు 0, ద డీవియేషన్ ఈజ్ ఈక్వల్ టు 0. సో కీప్ దట్ ఆల్సో ఇన్ అవర్ మైండ్, రైట్? So this can also be in our mind. So from this problem you have to keep all these formulas in our mind. ఒకటి ఈ lateral shift formula t of sin I minus r by cos r, ఇంకొకటి critical angle formula that sin c is equal to 1 by n, and one more is Snell's law n1 sin I is equal to n2 sin r, and you have to also keep this in our mind. deviation is equal to 0 ఎందుకంటే ఈ emergent ray as well as incident ray రెండు కూడా ఒకదానికొకటి ప్యారల్గా ఉంటాయి కాబట్టి. క్లియర్? సో దట్స్ ఆల్ అబౌట్ క్వశ్చన్ నెంబర్ 27. దట్ వాజ్ ద ఫస్ట్ క్వశ్చన్ ఇన్ రివిజన్ సిరీస్, right? Now look at the question number 28. That was the second one, so which will depend upon this apparent depth concept from the refraction. So first of all I'll just revise it, silly logics, then I will explain the problem, right? So in a refraction or coming to the apparent depth, right? So let's say the interface, one second, let it be interface. So interface is just a boundary which is separating a two medium. So paina medium 1 undanuko, kinda medium 2, paina medium 1 undi, kinda medium 2 undi, and now there are two mediums. Let's say this is air, పైన ఎయిర్ ఉందనుకో, కింద లెట్స్ సే దెర్ ఈజ్ అ మీడియం ఎయిర్, అండ్ లెట్స్ సే దెర్ ఈజ్ సమ్ అదర్ మీడియం ఎన్ హియర్. సో ఎయిర్ refractive index is 1 and the refractive index is n only. నౌ ఆబ్జెక్ట్ ఇక్కడ డెన్సిటీ మీడియంలో ఉండి ఇన్ కేస్ అబ్జర్వర్ ఎర్రర్ మీడియంలో ఉంటే వీ హ్యావ్ టు ఫైండ్ అవుట్ ఇమేజ్ పొజిషన్. సో దిస్ ఈజ్ ఆబ్జెక్ట్, అండ్ లెట్స్ సే ద ఆబ్జెక్ట్ పొజిషన్ ఈజ్ let's say the object position is xi, right? Sorry, xo. The object position is xo. ఇప్పుడు ఆబ్జెక్ట్ డెన్సిటీ మీడియం ఉండడం వల్ల ఏమైంది అంటే అది నీకు కొంచెం పైకి షిఫ్ట్ అయినట్టు కనబడుతూ ఉంటుంది. దేర్ఫోర్ ఇమేజ్ ఇక్కడెక్కడో ఉంది అనుకో ఫ్రమ్ ద ఇంటర్ఫేస్. సో ఇంటర్ఫేస్ నుంచి ఇమేజ్కి డిస్టెన్స్ వచ్చేప్పటికి సంథింగ్ లైక్ xi అనుకో, రైట్? దిస్ డిస్టెన్స్ ఈజ్ లెట్స్ సే xi. The distance is xi and there is a relation between those two. Relation is already done this derivation. The relation is, you could say this position of image from the interface will be equal to position of object from the interface by refractive index. So that was a relation that you need to keep in your mind. So this is a relation that you have to keep in your mind in order to solve the question number 28. ఆబ్జెక్ట్ అనేది డెన్సిటీ మీడియంలో ఉన్నప్పుడు అది కొంచెం పైకి షిఫ్ట్ అవుతున్నట్టు కనపడుతూ ఉంటుంది, అంటే ఉన్న డిస్టెన్స్ కంటే మనకు కొంచెం తక్కువగా కనపడుతుంది. రిపీటింగ్, ఆబ్జెక్ట్ డెన్సిటీ మీడియంలో ఉన్నప్పుడు ఉన్న డిస్టెన్స్ కంటే తక్కువ డిస్టెన్స్లో కనబడుతూ ఉంటుంది. సో ఇప్పుడు నార్మల్గా ఇంటర్ఫేస్ నుంచి ఆబ్జెక్ట్ ఎక్కువ డిస్టెన్స్లో ఉంటే ఇంటర్ఫేస్ నుంచి ఇమేజ్ అనేది ఎక్సై డిస్టెన్స్లో ఉంటుంది. ఇప్పుడు ఈ మధ్యలో గ్యాప్ ఉంది కదా, దట్ గ్యాప్ ఈజ్ కాల్డ్ యాజ్ అ షిఫ్ట్. సో ఆ గ్యాప్ని ఏమంటామంటే వీ కాల్ దట్ గ్యాప్ యాజ్ అ షిఫ్ట్. సో నౌ ఆ షిఫ్ట్ ఎంత అంటే ద డిఫరెన్స్ బిట్వీన్ దీస్ టూ, దట్ ఈస్ ఐ కుడ్ సే xo ఎక్కువ కాబట్టి xo minus xi. సో xo can be written as xo here, but xi can be written as a xo by n. Therefore I can write this as a xo of 1 minus 1 by n. So this is a shift that happens when the object is in a denser medium. సో ఆబ్జెక్ట్ అనేది డెన్సిటీ మీడియంలో ఉంటే నీకు అది దగ్గరగా ఉన్నట్టు కనపడుతుంది, అంటే నథింగ్ బట్ దట్ విల్ బి షిఫ్ట్ ఫ్రమ్ ఇట్స్ ఒరిజినల్ పొజిషన్, రైట్? ఆ షిఫ్ట్ ఎంత అంటే దిస్ అమౌంట్, ఇంత అమౌంట్ ఆఫ్ షిఫ్ట్ జరిగిద్ది. సో ప్లీజ్ కీప్ ఇట్ ఇన్ అ మైండ్ ద షిఫ్ట్ ఫార్ములా. ఎప్పుడు అంటే ఆబ్జెక్ట్ అనేది డెన్సిటీ మీడియంలో ఉన్నప్పుడు దట్ వాజ్ ద షిఫ్ట్ ఫార్ములా. నౌ దేర్ఫోర్ లెట్స్ సాల్వ్ ద క్వశ్చన్ నెంబర్ 28 సాల్వ్ చేద్దాం, రైట్? So that was the question number 28. Question is, there are two immiscible liquids of refractive index 8/5 and 3/2 respectively are put in a beaker as shown in the figure. The height of each column is 6 centimeters. A coin is placed at the bottom of the beaker. For near normal vision, the apparent depth of the coin is alpha by 4 centimeter. The value of alpha is. సో హియర్ అపరెంట్ డెప్త్ ఏంటి అంటే టోల్ యూ ఆల్రెడీ ఇన్ కేస్ ఆబ్జెక్ట్ డెన్సర్ మీడియం ఉన్నప్పుడు అది మనకి దగ్గరగా కనపడుతూ ఉంటుంది కదా, అంటే అది ఉన్న పొజిషన్ కంటే మనకు దగ్గరగా కనపడుతూ ఉంటుంది. సో ఎంత పొజిషన్ కనపడుతుందో దాన్ని ఏమంటామంటే అపరెంట్ డెప్త్ అంటాం. వేర్ దిస్ అపరెంట్ డెప్త్ ఈజ్ నథింగ్ బట్ దిస్ ఎక్స్ఐ ఈజ్ ఈక్వల్ టు ఎక్స్ బై ఎన్. బట్ ఇక్కడ 2 మీడియమ్స్ ఉన్నాయి కాబట్టి యూ కెన్ రైట్ దిస్ టోటల్ అపరెంట్ డెప్త్, రైట్. సో దెర్ ఆర్ 2 మీడియమ్స్ ఉన్నాయి కాబట్టి యూ కెన్ రైట్ ద టోటల్ అపరెంట్ డెప్త్ ఈజ్ ఈక్వల్ టు ఆర్ దట్ ఎక్స్ఐ ఈజ్ ఈక్వల్ టు యూ కెన్ రైట్ ద ఎక్స్ బై ఎన్ or xo due to the medium xo by n, plus you can also write as a xo 2 by n, or let's say n1 by n2, right, n1 by n2. So where this xo is nothing but this one, the thickness, and here also is nothing but a thickness, therefore that will be equal to this xo is how much, 6. So I could say 6 by refractive index of this one is nothing but 3 by 2, nothing but I'll have a 2 here, 3 here, plus xo2. So this xo2 is how much, this one is nothing but 6 again, so therefore 6 by 8 by 5. So this will be into 5 and this is 8 here, so this will be cancelled 2 times, so 2 here, and this will be cancelled like so 4 plus I can add as a 3 into 5, 15 by 4, 15 by 4, right. How much is it? This can be written as a 31 by 4, 31 by 4, therefore it is nothing but alpha by 4, answer is 31, therefore the answer is 31. So please keep it in mind, maybe there are some more problems based upon this logic. So this is all about apparent depth. That's all about apparent depth. So apparent depth anna as well as this image distance anna rendu okate in refraction anna plane surfaces lo. So please, for example, okay medium unte you could say xo by n, ikkada 2 mediums unnai kabatti we will take it about overall effect. So which is nothing but xo by n1 plus xo by n2, where that xo is nothing but ee particular medium yokka thickness enta ani. Clear? So that's all about refraction on a plane surface. So question number 28. Let's go to the question number 30. So question number 30 is again refraction on a plane surface. Let me take this image. I already explained this one in a theory part, మనం one shot చేసినప్పుడు చేసినాం, right. So question is that if fish is vertically upward with a uniform velocity 8 meter per second, if fish rising vertically upward with a uniform velocity of 8 meter per second, observe that bird is diving vertically downward towards the fish with the velocity of 12 meter per second. If the refractive index of water is 4 by 3, then the actual velocity of the diving bird to pick the fish will be. సో ఇక్కడ లాజిక్ నెంబర్ మెయిన్ లాజిక్ ఏంటి అంటే ఎవరెవరిని చూస్తున్నారు అని. సో ఇక్కడ ఫిష్ బోర్డ్ని చూస్తుంది, నాట్ బర్డ్ ఫిష్ని చూడట్లేదు. ఫిష్ బోర్డ్ని చూస్తుంది కాబట్టి బర్డ్ విల్ బి ద ఆబ్జెక్ట్ అండ్ ఫిష్ విల్ బి ద అబ్జర్వర్. ఫిష్ పైన ఎగురుతున్న బర్డ్ని చూస్తుంది కాబట్టి ఫిష్ విల్ బి ద అబ్జర్వర్ అండ్ బర్డ్ విల్ బి ద ఆబ్జెక్ట్. సో అప్పుడు ఆ ఆబ్జెక్ట్ ఎక్కడ ఉంది, నథింగ్ బట్ బర్డ్ ఎక్కడ ఉంది, ఎయిర్లో. అంటే ఆబ్జెక్ట్ రేర్ మీడియంలో ఉంది, అబ్జర్వర్ డెన్సర్ మీడియంలో ఉన్నాడు. హోప్ యూ రిమెంబర్ దోస్ ఫార్ములాస్. సెకండ్, let me say, so let's say interface, this is the interface, let's say it is an interface. Now let's say the fish is here inside the water, the fish is here and the bird is here, right. So now let's say that the distance between them or position of the fish and as well as the position of this, let's say this is the position of the fish from the interface, and let's say this is the position of the bird from the interface, right. So let's say this is position of the fish and this is the position of the bird. Now since the here ఈ బర్డ్ ఈజ్ ఆబ్జెక్ట్ నో. సో బర్డ్ అనేది ఆబ్జెక్ట్, ఎందుకంటే ఫిష్ బర్డ్ని చూస్తుంది కాబట్టి బర్డ్ అనేది ఆబ్జెక్ట్. ఇప్పుడు ఇన్ కేస్ ఆబ్జెక్ట్ అనేది ఎర్రర్ మీడియంలో ఉంటే ఇది మనకి ఉన్న డిస్టెన్స్ కంటే ఎక్కువ డిస్టెన్స్లో కనబడుతూ ఉంటుంది. ఉన్న డిస్టెన్స్ కంటే ఎక్కువ డిస్టెన్స్లో కనబడుతూ ఉంటుంది ఎప్పుడు అంటే వెన్ ఇట్ ఈజ్ ఇన్ రేర్ మీడియంలో ఉన్నప్పుడు ఉన్న డిస్టెన్స్ కంటే ఎక్కువ డిస్టెన్స్లో కనబడుతూ ఉంటుంది. సో యాక్చువల్గా ఇక్కడ ఉంది, లైక్ XB దగ్గర ఉంది, బట్ నీకు ఇది ఎక్కడ కనబడుతూ ఉంటుంది అంటే ఉన్న డిస్టెన్స్ కంటే ఎక్కువ డిస్టెన్స్లో కనబడుతూ ఉంటుంది. ఎంత ఎక్కువ డిస్టెన్స్లో కనబడుతూ ఉంటుంది అంటే ఎంత ఎక్కువ డిస్టెన్స్లో కనబడుతూ ఉంటుంది, ఎంత అంటే n/XB. సో దట్ ఈజ్ ఇక్కడ అంటే యాక్చువల్గా నీకు ఇక్కడ ఉన్నది కాస్త నీకు ఇక్కడెక్కడో కనబడుతూ ఉంటుంది. సో ఇప్పుడు ఈ ఫిష్కి ఎక్కడ ఉన్నట్టు కనపడుతూ ఉంటుంది అంటే ఇక్కడ ఉన్నట్టు కనపడుతూ ఉంటుంది. దేర్ఫోర్ ఇప్పుడు ఫిష్కి యాజ్ వెల్ యాజ్ ఈ అపరెంట్ బర్డ్కి ఉన్న గ్యాప్ ఎంత అంటే యూ కుడ్ సే దట్ దేర్ఫోర్ యూ కెన్ రైట్ యాజ్ ద పొజిషన్ ఆఫ్ ద ఫిష్, పొజిషన్ ఆఫ్ అ బర్డ్ విత్ రెస్పెక్ట్ టు ఫిష్. Position of the bird with respect to fish equal to, so position of a fish from interface as well as the apparent position of the bird from the interface. Apparent position of the bird from the interface, which can be written as a n/XB, right? So this is the one thing that you have to keep in your mind. So check it. The position of a bird with respect to fish is equal to position of the fish plus n/position of the bird. Therefore, if I differentiate it, I will get the velocities. Therefore, I can say it is nothing but a VBF will be equal to VF plus, I could say, which is nothing but n/VB. Therefore, you need to understand the sign convention also. Keep the sign convention in mind. So velocity of the bird with respect to fish will be positive or negative అంటే told you already in the one shot video. ఇన్ కేస్ ఇప్పుడు ఈ గ్యాప్ అనేది ఇంక్రీజ్ అవుతుంది అనుకో, ఈ రెండింటి మధ్య ఫిష్కి బర్డ్కి మధ్య గ్యాప్ ఇంక్రీజ్ అవుతూ ఉంటే VBF విల్ బీ టేకెన్ యాజ్ అ పాజిటివ్. అదే గ్యాప్ తగ్గుతూ ఉంటే దిస్ VBF విల్ బీ టేకెన్ యాజ్ అ నెగిటివ్. ఇక్కడ కూడా ఒకసారి ఇక్కడ సో ఫిష్ ఈజ్ వర్టికల్లీ if fish rising vertically upward with a uniform velocity of 8 meter per second, observe that a bird is diving vertically downward towards the fish. సో ఫిష్ పైకి మూవ్ అవుతుంది బట్ బర్డ్ ఏమో కిందకి మూవ్ అవుతుంది, అంటే ఈ మధ్యలో గ్యాప్ ఏమవుతుంది, డిక్రీజ్ అవుతుంది. రిపీటింగ్, ఫిష్ పైకి మూవ్ అవుతుంది, బర్డ్ కిందకి మూవ్ అవుతుంది. సో గ్యాప్ ఏమవుతుందంటే డిక్రీజ్ అవుతుంది కాబట్టి యూ హ్యావ్ టు టేక్ ఇట్ యాజ్ అ నెగిటివ్. అండ్ వాట్ అబౌట్ వెలాసిటీ ఆఫ్ ఫిష్ కెన్ బీ టేకెన్ యాజ్ అ పాజిటివ్ ఆర్ నెగిటివ్. ఇన్ కేస్ ఇక్కడ XF అనేది పెరుగుతుంది అనుకో విత్ రెస్పెక్ట్ టు టైం, దెన్ యూ హ్యావ్ టు టేక్ ఇట్ యాజ్ అ పాజిటివ్. ఇన్ కేస్ XF అనేది తగ్గుతూ ఉంటే యూ హ్యావ్ టు టేక్ ఇట్ యాజ్ అ నెగిటివ్. ఇన్ కేస్ ఇప్పుడు ఫిష్ పైకి పోతూ ఉంటే XF ఏమైంది, విల్ బి డిక్రీజ్, కాబట్టి VF విల్ బి నెగిటివ్. ద సేమ్ వే దిస్ VB ఆల్సో, ఇఫ్ దిస్ XB is increasing, that will be taken as a positive. If the XB is decreasing, that will be taken as a negative. Already explained everything in a one shot, but again revision kabatti we have to revise the number of times, so therefore, right? So now this will be minus VBF. You know that, have a look. Observe that the bird is diving vertically downward towards the fish with a velocity of 12 meter per second. So ఈ ఫిష్ యొక్క వెలాసిటీ బర్డ్కి ఎలా కనపడుతుంది అంటే 12 meter per second తో కింద కనపడుతుంది. Therefore I could say this is minus 12. You know why I am taking minus 12 here, right? And the fish velocity is given as the 8. Clear? So I'll have a minus side. Clear? So minus side plus, I know what is the refractive index, this can be written as here, again it is a minus, so minus 4/3 into VP, right? Everything will be minus, so all the minus get cancelled. So 12 equal to 8 plus 4/3 into VP. So if this comes as 4, so 4 is equal to 4/3 into VB. Therefore this 4 get cancelled. You could say this VB is equal to, how much is it, 3 meter per second. That might be the answer. VB is equal to 3 meter per second. That is the answer, right? So that's a question again on the refraction of plane surfaces. So the next question is question number 31. This is the question number 31. Again that is on the refraction of plane surface again, right? Question number 31. Let me take it out. This is the question number 31. An ice cube has a an ice cube has a bubble inside. When viewed from one side, the apparent distance of the bubble is 12 centimeter. When viewed from the opposite side, the apparent distance of the bubble is observed as a 4 centimeter. If the side of the ice cube is 24 centimeter, the refractive index of the ice cube is, we have to calculate the refractive index, right? Let me draw the diagram. So there is an ice cube, right? Say there is an ice cube. Now there is a bubble inside it, right? And there is a bubble inside it. We don't know this actual distances from the interfaces. Let me say this interface from this. So let's say from this interface, 1 second, let me change the color. From this interface, let's say it is at a x1 distance. From this interface, let's say it is at a x2 distance, right? Let me see it is at a x1 distance from this interface, and let me see it is at a x2 distance from this interface. Again the question, an ice cube has a bubble inside it. When viewed from one side, the apparent distance of the bubble is 12 centimeter. Now actually the bubble ikkada undi, but it chusta unte, that is seems to be like at a 12 centimeter. Now we are observer and this bubble will be like object. Now object is in a denser medium. The object is in a denser medium, therefore I told you already explained when the object is in a denser medium, what is the apparent depth formula? Revise it please. What is apparent depth formula? Apparent depth is equal to, or xi is equal to, you could say xo by n, right? So here xi is how much? That is 12 centimeter from this side. So 12 equal to xo can be like x1 by can write as the n. Therefore I can write this x1 is equal to 12n. Right, x1 is equal to 12n. Now if I look at from this side, this will be original distance is how much? x2, and the apparent distance will be how much? 4. So therefore I could say so now again apparent what is apparent depth formula? Apparent depth is equal to again xo by n. So therefore here this apparent depth is how much? 4 centimeter. Therefore 4 is equal to, what is xo? Xo is this x2, therefore I can write x2 by n again. X2 by n again, therefore this x2 is equal to 4 into n, right? And here we have to observe one more thing. The one more thing is that this total distance. The total distance is how much? This total distance is how much? Which is nothing but 24 centimeter. This total is how much? 24 centimeter. Therefore I could say this 24 is equal to x1 plus x2. The 24 equal to x1 plus x2, that is a one thing, or that is a main logic that will be helpful to solve the problem, right? This is the main logic here. So therefore 24 is 24 only. 24 is 24. I could say x1 is how much? 12n, and x2 is how much? 16n. Therefore the total is how much? 16n, right? Clear? Therefore I could say n is equal to 24 by 16. So let me cancel it. 4 table, how many times? 6 times. Here 4 times. Therefore again it will be like n equal to 3 by 2. N equal to 3 by 2. That is the answer for this problem, right? Clear? So next solve the problem number 34. No, 32. Now let's solve the problem number 32. That 32 is important again. That is also a refraction concept. Refraction on a plane surface concept. Question number 34. Let me take it out. 32. Sorry. Question number 32. No need. Just let me take out this diagram. Here. This is the one, and this kind of questions are important conceptually, so they will increase our concepts on reflection on a plane surface. Now the question is, As shown in the figure, a plane mirror is fixed at a height of 50 centimeters. So this mirror is at a 50 centimeter and there is a object here. So now what is the distance between the image as well as this bottom? ఇప్పుడు ఈ మిర్రర్లో ఈ ఆబ్జెక్ట్ ఇమేజ్ ఫామ్ అయింది, ఈ మిర్రర్లో ఈ ఆబ్జెక్ట్ ఇమేజ్ ఫామ్ అయింది కదా, ఆ ఇమేజ్కి ఈ బాటమ్కి మధ్యలో గ్యాప్ ఎంత అని. నౌ వేర్ దిస్ ఆబ్జెక్ట్, ఈ ఆబ్జెక్ట్ ఎక్కడ ఉంది? డెన్సర్ మీడియంలో. రిపీటింగ్, ఈ ఆబ్జెక్ట్ ఎక్కడ ఉంది? డెన్సర్ మీడియంలో. డెన్సర్ మీడియంలో ఉంటే ఏమైంది? ముందుకు షిఫ్ట్ అయినట్టు కనపడుద్ది, ముందుకు షిఫ్ట్ అయినట్టు కనపడుద్ది, రైట్? ఆ షిఫ్ట్ ఎంత? షిఫ్ట్ ఫామ్లో వాట్ ఇస్ ద షిఫ్ట్ ఫామ్లో? So therefore, if you remember the shift formula, shift is equal to, you could say shift directly. So shift equal to, I could say this shift. So shift equal to, or shift kante better, let's say image, apparent image. So let's say xi is equal to xo by n. Xi equal to xo by n. So that was important. Right. So xi is equal to xo by n. What is the xo here? That is 8. So interface నుండి 8 centimeter distance లో ఉంది. So therefore I could say xi equal to, xi is equal to what is the xo? Xo is how much? 8 by refractive index. Refractive index of water is how much? 4 by 3. So 4 here into 3 here. This will be like 6. So that is apparent depth is a 6 centimeter. So nothing but interface నుంచి ఎంత డిస్టెన్స్లో ఉంటుంది అంటే 6 centimeter డిస్టెన్స్లో ఉంటుంది. Let me represent it. So that will be interface nunchi, right? So from the interface that will be at a 6 centimeter, right? You know this total distance is 50, and now this distance is how much? What is this distance? 42, right? This distance will be only 42 because already the 50 is 8 and this will be only 42. This will be only 42, right? ఇప్పుడు ఇంటర్ఫేస్ నుంచి ఎంత డిస్టెన్స్ ఉంది? 6 మీటర్. అంటే ఇప్పుడు ఈ డిస్టెన్స్ ఎంత అంటే, ఏ డిస్టెన్స్? 1 సెకండ్. కెన్ యూ గెస్ ద డిస్టెన్స్ బిట్వీన్ దిస్ వన్? వాట్ ఇస్ దిస్ డిస్టెన్స్? 48. హౌ మచ్? 48. ఎలా 48 అంటే? 1 సెకండ్, సారీ. సో దిస్ డిస్టెన్స్ విల్ బీ 48. సో 48 ఎలా అంటే ఈ డిస్టెన్స్ ఎంత? 42. అండ్ ఇప్పుడు ఇంటర్ఫేస్ నుంచి నీకు ఎంత డిస్టెన్స్లో కనపడుతూ ఉంటుంది? ఇంటర్ఫేస్ నుంచి అది ఉండడానికైతే 8 centimeter డిస్టెన్స్లోనే ఉంది, బట్ నీకు ఎంత డిస్టెన్స్లో కనపడుతూ ఉంటుంది? 6 centimeter డిస్టెన్స్ కనపడుతూ ఉంటుంది. సో ఇది 6, ఇది ఆల్రెడీ 42. అప్పుడు ఈ డిస్టెన్స్ ఎంత అంటే 48. సో దేర్ ఫోర్ ఇఫ్ యూ రిమెంబర్ దిస్ ప్లేన్ రిఫ్లెక్షన్ ఆఫ్ ప్లేన్ సర్ఫేస్, ఇఫ్ యూ రిమెంబర్ ద రిఫ్లెక్షన్ ఆన్ ద ప్లేన్ సర్ఫేస్, లెట్స్ సే దిస్ ఈజ్ అ మిర్రర్. Let's say this is a mirror and let's say there is a object here. Let's say there is an object here and the object is at a distance of 48 centimeter. Let's say this object is at a distance of 48 centimeter and you know this image will also form at a 48 only. Object ఎంత డిస్టెన్స్లో ఉందో ఇమేజ్ కూడా అంతే డిస్టెన్స్లో ఉంటుంది ఇన్ అ ప్లేన్ మిర్రర్ కాన్సెప్ట్. సో దిస్ ఈజ్ అ 48 centimeter. This will be also how much is it? 48 centimeter only. Clear or not clear? Clear, right? సో ఇప్పుడు ఇది 48లో ఉంది, బ్యాక్ సైడ్ 48లో ఉంది, బ్యాక్ సైడ్ 48లో ఉంది. ఇక్కడ నుంచి ఇమేజ్ ఎక్కడ ఫామ్ అవుతుంది? పైన ఎక్కడ 48లో ఫామ్ అవుతుంది. ఇది 48, ఇదంతా బాటమ్ దగ్గరికి ఎంత? 50. దేర్ ఫోర్ ఆన్సర్ ఎంత అంటే ఇది ఒక 48 ఈ లోపలికి ఈ బాటమ్ దగ్గర. లెట్ మీ రిప్రజెంట్ బై యూజింగ్ అ డయాగ్రామ్. సో లెట్స్ సే ఇట్ ఈస్ అ బాటమ్ నో. ఇలా బాటమ్ ఉందనుకో, ఇప్పుడు ఈ బాటమ్కి ఈ ఇమేజ్కి లెట్స్ సే ద ఇమేజ్ ఇస్ ఫార్మింగ్ హియర్, రైట్? దట్ ఇమేజ్ ఈజ్ ఫార్మింగ్ హియర్. ఇప్పుడు ఆ ఇమేజ్కి ఈ బాటమ్కి మధ్యలో గ్యాప్ ఎంత అంటే దట్ గ్యాప్ కెన్ బి హౌ మచ్ ఇస్ ఇట్? ఈ గ్యాప్ ఎంత అంటే ఇది ఒక 48. ఇది ఎంత? బాటమ్ దగ్గర గ్యాప్ ఎంత ఉంది అంటే ఎంత ఉంది? మిర్రర్ నుంచి బాటమ్కి డిస్టెన్స్ ఎంత ఉంది? 50 ఉంది. సో దిస్ ఈజ్ అ 50, ఇది ఒక 50, అదొక 48, ఇది ఒక 50, అదొక 48. సో టోటల్ ఈజ్ హౌ మచ్? టోటల్ ఈజ్ ఈక్వల్ టు 98 centimeter. దట్ ఈస్ ఆన్సర్. Total is 98 centimeter. That was the answer, right? Now let's solve the question number 35. That's also important. Solving question number 34. Solving the question number 34, right? So just check it once. Question number 34. So there was a question number 34. Question is, a pole is vertically submerged in a swimming pool such that it gives a length of a shadow 2.15 meter within a water when sunlight is incident at an angle of 30 degrees with the surface of water. If the swimming pool is filled to a height of 1.5 meter, then the height of the pole above the water surface in centimeter is, right? So let me draw the diagram first, then we will solve the problem. Now let's see, it is the bottom, right, and the water level is up to here, right? Now we have a pole, a pole is like this, right? Now the water level is how much? Water level is up to 1.5 meters. Therefore this distance is how much? This is, sorry, so this is 1.5, right? This is 1.5 meters. That is 1.5 meters. Now we have to find out this extra height in a air, right? Let's take a ray from the top. Let's take a ray from the top. So from the top there is a ray here that is incident on this water, and now the sunlight is incident at an angle of 30 degrees with the surface of the water. So this angle is 30 is not with the vertical, it is with the surface of the water. So let's say there is a vertical line over here. This is the 30 degrees with the horizontal. Therefore if it is 30 degrees, then this will be like how much? 60 degrees. This will be like a 60 degrees. It is a 30 degrees, and you don't know this height x, right? Now when the light is moving from air to water, that is moving from rarer to denser. Therefore that will move close to the normal line. So that moves to the close to the normal line like this. Clear? Now I'm just extending it. Clear? Now here he is mentioning that this distance, here he mentioned this distance is how much? So which is nothing but a 2.15 meter shadow, which is 2.15 meter shadow, which is 2.15 meter shadow. So this is a diagram that you need to be understand. Now what is this distance? So from this right angle triangle you can write this tan 30. Is it? You can write as a tan 30 equal to, so therefore tan 30, you can write as a tan 30 is equal to opposite by what? Opposite by adjacent. This adjacent, how much is it? Let's say maybe whatever, let's say it is a y. Therefore you could say this y equal to, right, I could say this y is equal to x by tan 30. X by tan 30 is nothing but root 3. Therefore that will be like a root 3 into x. So therefore this distance is how much? Root 3 into x. If it is a root 3x, this will be also root 3 into x only, right? Now I would like to find out this one. In order to find out this one, I have to use a Snell's law over here. This point దగ్గర Snell's law apply చేయాలి. So therefore if I apply the Snell's law here, therefore what is the Snell's law formula? N1 sin I is equal to, I could say N2 sin I. That is the Snell's law. Just keep that in our mind. So just so N1 sin I is equal to N2 sin R. Therefore what is N1 here? That was the air. So therefore 1 and sin 60. So that is nothing but sin 60 will be equal to N2 is how much? Water, given at 4 by 3. So 4 by 3 into sin R. 4 by 3 into sin R. Therefore this sin 60 is how much? Root 3 by 2. So this is nothing but root 3 by 2 will be equal to 4 into sin R. 4 into sin R. Therefore sin R equal to how much is it? 8 by root 3 by 8. Sin R equal to root 3 by 8. Clear? Sin R is equal to root 3 by 8. Now I have to find out, I already find this angle, I wanna find out this one. What is R here? So 1 second, I wanna find out that R. Therefore this r is equal to sine inverse of root 3 by 8. So I have to find out sine inverse of root 3 by 8. Now I get this r, right? And I know this is nothing but a 1.5. Now I have to find out this distance. This distance enta ante I could say again from this tan r. Therefore I could say tan r equal to, what is the tan r? I could say opposite by, let's say opposite is z now, something like opposite is a z, by I can write as a 1.5. Therefore this z is equal to, I can write as a 1.5 into tan r, right? So I could say from here I can find out the sin r value, you know, right angle triangle. So you can take it as a right angle triangle, and if it is root 3 and it is 8, you can find out this value, and from that you can find out this tan r value, and if you can substitute it. Therefore the main logic is that, so this one, how much is it? So this is root 3x, this is a root 3x plus this is 1.5 into tan r, that will be equal to, how much is it? So 2.15. So just do it, you will get the answer, right? Just solve it, you will get the answer, 2.15 meters. Clear? So that is the question number, how much? 34. And now go to the look at question number 35. Right. Moving to the question number 35. So even this 35 is also important. Question number 35, let me take it out. Question number 35. A microscope is focused on an object at the bottom of a bucket. If liquid with refractive index of 5/3 is poured inside the bucket, then microscope have to be raised by 30 cm to focus the object again. The height of the liquid in the bucket is. Repeating a question, a microscope is focused on an object at the bottom of a bucket. If the liquid with refractive index is 5/3 is poured inside the bucket, then the microscope have to be raised by 30 cm to focus the object again. The height of the liquid in the bucket is, let's say the bottom of the bucket first. So let's say the bottom of the bucket is the bottom of the bucket. అక్కడ ఒక ఆబ్జెక్ట్ ఉంది, ఆ బాటమ్ దగ్గర ఒక ఆబ్జెక్ట్ ఉంది. నా దీని మీద ఒక మైక్రోస్కోప్ పెట్టి ఈ ఆబ్జెక్ట్ని చూస్తున్నాం. ఇప్పుడు ఏం చేస్తున్నామంటే ఈ బకెట్లో వాటర్ పోస్తున్నాం అప్ టు సర్టన్ హైట్, వి డోంట్ నో దట్ హైట్ వాల్యూ. ఈ బకెట్లో వాటర్ పోస్తున్నాం, ఆ వాటర్ హైట్ కూడా మనకు తెలియదు. లెట్స్ సే సమ్ హైట్, ఎంతకంత వాటర్ పోస్తున్నాం అనుకో, లెట్స్ సే ఇంత లెవెల్ వరకు వాటర్ పోసాం అనుకో, రైట్? ఇంత లెవెల్ వరకు వాటర్ పోస్తున్నాం, అంత లెవెల్కి వాటర్ పోస్తున్నాం. ఎంత లెవెల్ అంటే మేబీ హైట్ హెచ్ అనుకో. నౌ ఇట్ ఈస్ లైక్ అపరెంట్ డెప్త్ కాన్సెప్ట్, రైట్? పైన చూస్తూ ఉంటాయి. ఇప్పుడు ఈ ఆబ్జెక్ట్ ఎక్కడ కనబడుతుంది? పైకి కనబడుతూ ఉంటుంది. ఇప్పుడు ఈ ఆబ్జెక్ట్ ఇందాక వరకు ఎక్కడ ఉంది? ఈ ఆబ్జెక్ట్ ఎయిర్లో ఉంది. బట్ నువ్వు ఎప్పుడైతే వాటర్ పోసావో ఆబ్జెక్ట్ ఎక్కడికి వచ్చింది? ఎయిర్లోకి వచ్చింది. ఆబ్జెక్ట్ ఎయిర్లోకి పోతే ఏమైంది? పైకి షిఫ్ట్ అయ్యింది, లేకపోతే అపరెంట్ డెప్త్ మారిద్ది. అంటే ఒరిజినల్ డెప్త్ ఎంత అయితే ఉంది నీకు అంత డెప్త్లో కనపడదు, మారిద్ది. సో దెర్ ఫోర్ వాట్ ఇస్ దట్ అపరెంట్ డెప్త్? What is that apparent depth? Apparent depth is equal to, what is the apparent depth formula? Xi is equal to xo by n, right? And ఇప్పుడు you have to focus, and for example ఇప్పుడు ఇంటర్ఫేస్ నుంచి, one second I will explain in detail, right? ఇది ఒరిజినల్ డెప్త్, ఇంటర్ఫేస్ నుంచి ఇంత డిస్టెన్స్లో ఉంది. ఇన్ కేస్ ఇప్పుడు మనం వాటర్ పోస్తే ఏమైంది? ఇన్ కేస్ మనం వాటర్ పోస్తే అది ఎక్కడెక్కడో కనబడుతూ ఉంటుంది. ఒరిజినల్ ఎంత అయితే ఉందో అంత కనపడకుండా నీకు ఇక్కడే కనపడుతూ ఉంటుంది. సో దిస్ వన్ ఈజ్ కాల్డ్ యాజ్ ఎక్స్ఓ అండ్ దిస్ ఈజ్ కాల్డ్ యాజ్ ఎక్స్ఐ. ఇప్పుడు నీకు ఇంత డిస్టెన్స్ ఇది షిఫ్ట్ అయ్యింది. ఈ డిస్టెన్స్ ఎంతైతే ఉందో అంత డిస్టెన్స్ నీకు ఆబ్జెక్ట్ అనేది షిఫ్ట్ అయ్యింది. ఈ షిఫ్ట్ ఎంత అంటే యూ కుడ్ సే దట్ షిఫ్ట్ ఈజ్ ఈక్వల్ టు, యూ కుడ్ సే దట్ షిఫ్ట్ ఈక్వల్ టు దిస్ వన్ మైనస్ దిస్ వన్, దట్ ఈజ్ xo minus xi. That will be like xo is how much? What is xo? Where this xo is how much? H minus xi is how much? H by n again. Therefore if you take out this h out, you can add the 1 minus 1 by n, right? And here this shift is given as a 30. అంటే ఇందాక ఇక్కడ వరకు ఫోకస్ అయింది, ఇప్పుడు ఎక్కడ ఫోకస్ అవ్వాలి? ఇక్కడ ఫోకస్ అవ్వాలి. ఇందాక నువ్వు ఎక్కడ ఫోకస్ చేస్తున్నాను, ఇప్పుడు ఇక్కడ ఫోకస్ చేయాలి, ఎందుకంటే నీకు ఇప్పుడు ఇమేజ్ ఇక్కడ కనపడుతూ ఉంటుంది కాబట్టి. విచ్ ఈజ్ ఆల్సో హౌ మచ్ ఇస్ ఇట్? 30. So therefore 30 is equal to h is how much? H is we don't know, that is what we have to calculate. 1 minus water kabatti here refractant is ichinaadu, so 1 minus 1 by n ante it can be written as a 3 by 5. Therefore this 30 is 30 only, h is h only, can be written as a 2 by 5, right? 2 by 5. So this is how much? 150, right? 150 will be equal to 2h. Therefore h is equal to 75 centimeter. H is equal to 75 centimeter. Here you have to remember these two formulas well. So one is the shift formula, other one is this apparent depth formula. So these two formulas are important in order to solve this question, so please check it. Right, so that was the question number 35. Now let's solve about the question number 37. So question number 37. So this is question number 37, which is depend upon the vector form of a refraction, right? So that is a new concept again, vector form of refraction. Question number 37 is on refraction vector form, right? So let me say that there is a interface. ikkada oka idi interface anuko, ఇది ఇంటర్ఫేస్, ఇది నార్మల్ లైన్, దిస్ ఈజ్ ద నార్మల్ లైన్. సో వన్ సెకండ్, సారీ. Let's say interface and let be normal line. So I'm taking just an incident ray like this. So this is incident ray, and let's say this is a refracted ray, like so. One is incident ray, other one is a refracted ray, right? Now in this incident ray is incident along this one, this incident ray is incidenting along this unit vector, and this refracted ray is refracting along this, passing along this unit vector. So this, let's say this unit vector is I cap, and let's say this unit vector is how much? Let's say it is nothing but r cap, and there is a normal line. This normal line is along some direction, right? That is nothing but n cap. And you know this angle is called as angle of incident, and this angle is called as angle of refraction. So this is called as I, and you know this is called as r. So then I antam, then r antam. Now we know the Snell's formula. What is the Snell's formula? You could say n1 sin I is equal to n2 sin r. n1 sin I equal to n2 sin r. n1 sin I is equal to n2 sin r, right? So that was important always. n1 sin I is equal to n2 sin r. Now you know that vectors concept. I can write this sin I, or from here this is I cap, this is I cap, and this is n cap. So if I just extend this I cap, one second. If I just extend this I cap, sorry, if I just extend this I cap like this, like what? Like this. If I just extend this I cap like this, now the angle between this n cap and I cap is how much? This angle. The angle between this n cap and I cap is how much? This angle. What is this? So this total is 180, and this will be nothing but 180 minus I. This will be nothing but 180 minus I. Therefore if I talk about this cross product of these two I cap and n cap, I could say I cap cross n cap equal to I cap cross n cap is equal to, I can write as a 1 into 1 into sine, sorry, 1 into 1 into, I can write as a sine 180 minus I. I can write as sine 180 minus I. Sine 180 minus I can be written as a sine I. Therefore I could say sine I. So therefore in the place of sine I can write as this I cap cross n cap. In the same way, the angle between these two, what? This n cap and r cap. This n cap and r cap again 180 minus r. Therefore again I can write as r cap. If I find out this r cap cross n cap, that will be equal to 1 into sine 180 minus r again. That will be equal to how much? Sine r. Therefore this can be written as, so n1 I bar cross I cap cross n cap will be equal to, so this is n2, this is r cap cross n cap. This is a vector form of a refraction, or vector form of a Snell's law. That was a vector form of a Snell's law. So please keep that in your mind. That will be used to find out a direction of different refracted ray. One second, sorry. So mind it. This one. So n1 a cap cross n cap is equal to n2 into r cap cross n cap. So this n1 is the refractive index, this n2 is also refractive index. They both are refractive index, please keep that in mind, right? But this n cap is what? This is a normal line direction, right? Now let me take out that question, but that question is different from this. The question is this one. So there was a question. The question is, the xy plane be taken as boundary between the two transparent media m1 and m2. Two transparent media m1 and m2. m1 in z greater than 0 has a refractive index of root 2, and m2 with the z less than 0 has a refractive index of root 3. A ray of light traveling in m1 along the direction is given by a bar is equal to 4 root 3 I cap minus 3 root 3 j cap minus 5 k cap is incident on the plane of separation. The value of difference between the angle of incident in m1 and the angle of refraction in m2 will be, right? Now the xy plane is taken as a boundary between the two transparent media. xy plane ni manam ippudu boundary kin తీసుకుంటే this normal line will be along a z axis, right? So let me represent like this. So let's say, one second, sorry, this is, let's say that is the interface. Now if I draw the normal line will be along what? Along a z axis. The normal line will be along a z axis. The normal line will be along a z axis, right? So z greater than 0 having a refractive index of root 3. This is having a refractive index as a root 3, and this is having a refractive index of root 2. That is having refractive index root 3, and kinda meaning వచ్చేప్పుడు refractive index ఉంటుంది root 2 ఉంది, right? Now there is a ray which is passing like this along the direction given by the vector a bar is equal to 4 root 3 I cap minus root 3 j cap. So now there is a ray which is incident from one medium to other medium like this, right? Like this. Now it is making some angle with the z axis. That will make some angle with the z axis. Let's say this angle is the z axis, now theta, right? And you know this can be written as a bar is equal to 4 root 3 I cap minus 3 root 3 j cap minus 5 k cap. So along z axis, what is the component and how much is it? 5. Along that, how much and you could say it is nothing but a 5, but it is moving like maybe opposite lo potundi anukunta. Endukonte it is nothing but minus 5 k cap, maybe that is moving in opposite. That was moving in opposite, so anyway, just keep it, we'll solve it, right? There was a thing. Now in order to solve this, you have to understand this like a cosine problems, or like there is a direction of cosines concept, right? In a vectors you need it. So let me explain that. In order to solve this problem, you need to understand this direction of a cosines. I will explain that. One second. What is the direction of cosines? Let's say this is y-axis, let's say this is x-axis, let's say this is a z-axis. Z-axis is actually outside, but we are not able to draw, right? So therefore, if I take a vector maybe that passes through like this, if I am talking about a vector that is passing like this in a space, nothing but in a 3-dimensional, if the vector is passing like this in a 3-dimensional, if it is making theta or alpha with this x-axis, if it is making gamma with the y-axis, and if it is making beta with the z-axis, right? Then you can write this. For example, if I take it as a, I mean this vector is having a magnitude as a, that vector is having a magnitude a. If I split into components, then component చేస్తే along x-axis will have a one component, along y will have a one component, and along z will have a one component. Therefore, along x the component is, if you remember these vectors, along x the component is ax is equal to, I can write as a into cos alpha, right? So I could say this a y is equal to a into sin alpha, a into sin gamma, and a z is equal to a into cos, sorry here, my mistake, a into, this is a into cos gamma, and this is what, a into cos beta, right? So from this I can write as this cos alpha. I can write as the cos alpha as, so what is the cos alpha? Cos alpha is equal to a x by a. I can write the sin alpha, sorry, cos gamma, my mistake. అస్తమానం మనకి సైన్ అలవాటు అయిపోయి వచ్చేస్తున్నాయి. cos gamma is equal to a y by a, as well as cos beta. This cos beta can also be written as what? A z by a. So this cos alpha, cos gamma, cos beta are called as direction of cosines. So now we're gonna solve this problem again by using this direction of a cosine. So here z angle తో ఫామ్ చేసేది ఎంత అంటే theta. ఇక్కడ z తో or z axis తో ఫామ్ చేసేది అంటే ఎంత? That angle is theta. Therefore using the same concept of direction of cosines, I'm using the direction of cosines concept in order to solve the problem, right? So therefore by this I can write as this cos theta. I can write this cos theta is equal to, what is the cos theta? Cos theta is what is that? Az here. This Az is 5. That Az is a 5 by a. A is nothing but under root of, we have to find out the magnitude of it. That is under root of a 4 root 3. 4 root, sorry, this is 4 square root 3 square plus 3 square root 3 square plus you have to write as a 5 square. So if you do it, you will get some cos theta. So cos theta is equal to 5 by, right, again it is a 16 into 9 plus 9 into, sorry, 16 into 3, 16 into 3 plus, how much is it? 9 into 3 plus I can add as a 25. This is under root, right? So 16 into 3 how much? 48. So 5 by under root of 48 plus 9 into 3 27 plus 25. So it is maybe like a single silly calculation, seems like. So let me rub it, no need of it again, right? This can be written as cos theta. Therefore I can write this as cos theta is equal to 5 by 100, 5 by root 100 is nothing but 5 by 10. Therefore this theta is equal to cos theta. Cos theta is equal to how much I get? I get it as a 1 by 2. Therefore theta equal to 60 degrees. The theta is equal to 60 degrees. Therefore you have to find out the value of difference between the angle of incident and what is this? Angle of incident and angle of refraction. I get that angle of incident is a 60. Therefore I can use the Snell's law now. This one I can use the Snell's law. N1 is how much? Root 3. So root 3 into sine 60. Root 3 into sine 60 equal to root 2 into, how much is it? Root 3 into sine r. I don't know what is the sine r is. Sine r only. So root 3 is root 3. The sine 60 can be written as root 3 by 2. Can be written as a root 2 into sine r, right? So this is nothing but it can be written as a 3. Something is here. There is a mistake here. What is a mistake? Sine 60 is how much? Root 3 by 2. So this is nothing but 3 by 2. 3 by 2 root 2. This is root 2 in down, or I could say root 2 here. So let me say what is a root 2 here. What is it? So root 2 into sine 60 root 3 by 2. Again root 2, root 2, root 2 cancel here. Therefore sine r equal to sin r equal to how much is it? Root 3 by 2. Again that is 60. How that will be 60? That won't be 60, right? root 2 sin 60 is equal to root 2 into sin r will be equal to root 2. So root 2, if it is moving కింద నుంచి పైకి పోతుంది అనుకుంటే root 2 into sin 60. Sin 60 is how much? Root 3 by 2 will be equal to, this one is root 3. So now this root 3 get cancelled, right? 1 second, there is some silly calculation mistake. Sorry for that. So if it is moving from కింద నుంచి పైకి పోతుంది అనుకుంటే ఏమైంది అప్పుడు అలాగా root 2 into sin 60. root 2 into sin 60 is equal to root 3 into sin r. Sorry for the calculation mistake. root 2 into sin 60 is root 3 by 2 will be equal to root 3 into sin r. So this root 3 cancel, this will be cancelled. Therefore I could say that sin r is equal to 1 by root 2. Sin r is equal to 1 by root 2. Therefore r is equal to 45 degrees. R equal to 45 degrees, right? R equal to 45 degrees. Therefore you can find out the answer. What is the angle between those two? Malli cleanly. Right, let me draw the diagram again. Sorry for the calculation mistake, don't mind. Just take it in a reverse order, that's why. Right. So this is how much is it? This is 60 degrees and this is a 45 degrees. Now what is the angle? The value of difference between the angle of incident and the angle of refraction is how much? 15 degrees. Therefore the answer is 15 degrees, right? This is the answer. So sorry for the calculation mistake. So that was all about question number 37, right? Now let's solve the question number 31. Sorry, question number 37 is over. Let's see question number 39. So this 39 has a special importance, so please have a look. Let me take it out. Question number 39, this one. Question number 39. As shown in the figure, after passing through the medium 1, the speed of the light is v2 and a medium 2 will be. So we have to find out the velocity of light in this medium, and you know the relation between those two, that is, you know, the refractive index formula. It is from the basic n is equal to c by v. N equal to c by v. So that was the one important formula that you have to keep in mind. That is only basic formula here. So n is equal to c by v. And therefore, you know, one more formula that you have to keep in mind, you know, like a C formula from this electromagnetic waves, if you remember, C is equal to 1 by under root of mu naught and epsilon naught, under root of mu naught and epsilon naught. If it is a V, we could say V is equal to 1 by under root of what? Mu and epsilon, where that mu and epsilon are permittivity and permeability. So therefore, you can write it as, you have to keep these formulas also in your mind. So this one in our mind as well as this one is also in our mind, right? So therefore you can write this n is equal to c by v. Therefore if I write this as, if I rewrite the terms, that will be like mu r under epsilon r. That is a refractive index formula. Therefore n is equal to mu r is how much? 9 here, and sorry, mu r is 1 and epsilon is 9 here. Therefore n is equal to 3 for this medium. The medium refractive index ante n is equal to 3. Therefore guys, n equal to c by v, right? So you know v is equal to c by n here. V will be equal to c by n. So c is how much? 3 into 10 power of 8 by n is how much? 3. So this one is going to get cancelled. Therefore v is equal to 10 power 8 meter per second. V is equal to 10 power of 8 meter per second. That was the answer for question number 39, right? Now let's go with the question number 41. So that's also similar kind of a question, right? Question number 41. Let me take out the question. This is the question number 41. The time taken by the light to travel in two different materials A and B of refractive index mu A and mu B of the same thickness is T1 and T2 respectively. If T2 minus T1 is equal to 5 into 10 power minus 10 seconds and the ratio of mu A to mu B is 1:2, then the thickness of the material in meters is, we have to find out a thickness, right? So read the question again. The time taken by light to travel in two mediums of different materials of refractive index Na and Nb of the same thickness is T1 and T2. So both are having the same thickness. Let me draw the diagram. So there is a one medium here, and let's say there is a one more medium here, right? So both are having the same thickness. The thickness is same for both, right? It is having the thickness as a T and it is also having the thickness as a T. So this is having a thickness as a T and it is also having a thickness as a T. Both are having the same thickness. Now the light is traveling in both the mediums, right? Now the light is traveling in both the medium. Deenlo potundi as well as deenlo kuda potundi. Clear? Now the time difference, let's say here T1, the time is T1 here. Let's say the time is T1 here, let's say the time is T2 here. So therefore, time can be written as, or before that velocity is equal distance by time. So velocity can be written as C by n from the previous. C by n is equal to velocity, this distance is how much, T by time is how much, let's say T1 here. So therefore this T1 is equal to, I could say it is nothing but nt by C or n1t by, I could say C. In the same way I could say T2 is equal to T2 and the n2t by C, right? So therefore this T1 minus T2 will be equal to, if I take out T out by C out, I can add as a n1 minus n2, right? n1 minus n2. n1 minus n2, what is the T1 minus T2? This is nothing but T1 minus T2 is 5 into 10 power minus 10. 5 into 10 power minus 10 will be equal to T by C into n1 and n2. They both are in the ratio of 1:2, right? Mu A to mu B. That is, since n1 by n2 equal to 2, therefore n1 equal to, here the answers are in a VA and a VB. So I could say this n1 equal to 2 into n2. n1 equal to 2 into n2. Therefore I could say it's nothing but 2 n2 minus n2. 2 n2 minus n2. So therefore I could say thickness T is equal to, how much is it? Thickness T is equal to 3 into, or let me say 5 into 10 power minus 10 into C by n2, right? So therefore thickness T is equal to 5 into 10 power minus 10 into this C can be written as, the velocity V is equal to, what is the velocity? For example V2, if I am talking about, so V2 is equal to, I could say V2 is equal to almost C by n2, right? Therefore the C by n2 can be written as a V2, that V2 is nothing but VB here, right? So therefore this thickness T is equal to 5 into 10 power minus 10 into V2 or VB, or, right? That was the answer. That was the answer for question number what? Question number 41. That was answer for question number 41. Let's talk about a question number 42, right? Others also may be kind of a similar problem. Let's talk about a question number 42. Question number 42, this one. So let me take out the problem. Let me take out the problem from the book. So preparation alone, guys. Ella chestunna preparation anta. Hope preparing for well. బాగా ప్రిపేర్ అవుతున్నానని అనుకుంటున్నాను. అందరూ బాగా ప్రిపేర్ అవ్వండి, ఎన్ఐటీలకు పోండి, లైఫ్ ఎంజాయ్ చేయండి, రైట్. సో క్వశ్చన్ నెంబర్ 42 is this one. The speed of a light in a medium A and a B are 2 into 10 power centimeter per second and 1.5 into 10 power 10 centimeter per second respectively. A ray of light enters from the medium B to A at an incident an angle theta. If the ray suffers a total internal reflection, then we have to calculate theta only. The speed of light in a medium A and B are 2 into 10 power 10 centimeter per second and 1.5 into 10 power 10 centimeter per second. So here is given as speed of light. So from the speed of light you have to find what refractive index is. Clear? So therefore let me draw the diagram first, then we will solve the problem. This interface is it. Now the light is moving from one medium to other medium. The light has to move from one medium to other medium. So it separates the two medium 1 and medium 2. So let's say this is the rarer and let's say this is the denser. So you know that ఇక్కడ టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్ జరుగుతుంది. అలా జరగాలంటే లైట్ ఎప్పుడు కూడా డెన్సర్ నుంచి రేరర్లోకి ట్రావెల్ అవ్వాలి. సో therefore I could write the diagram like this. So this is incident ray and this is a reflected ray. The total internal reflection is happening. If the ray suffers a total reflection, then the theta should be like this incident angle. This incident angle should be greater than critical angle, right? So this theta should be greater than the critical angle. The theta should be greater than critical angle. So ఇక్కడ దీంట్లో ఇప్పుడు ఏది వెలాసిటీ అంటే వెలాసిటీ ఇస్ హౌ మచ్ 2 into 10 power 10, ఇంకోటి 1.5 into 10 power 10. సో రేర్ మీడియంలో 2 into 10 power 10 ఉంటుంది బికాస్ రేర్ మీడియంలో వెలాసిటీ ఎక్కువ కాబట్టి. అండ్ హియర్ ద వెలాసిటీ ఇస్ హౌ మచ్ ఇన్ డెన్సర్ మీడియం 1.5 into you could say 10 power 10. 1.5 into 10 power 10. We have to find out the refractive indexes, right? So what is the refractive index of rarer medium? Refractive index of rarer medium is equal to, how much is it? So we can do the 3 into 10 power 8 by 2 into 10 power 8. And refractive index of a denser medium. Refractive index of denser medium is equal to how much is it? Again 3 into 10 power 8 by how much is it? 1.5 into 10 power of 8, right? And I have to find out this C here, you know, like sin C. So sin C is equal to how much is it? Sin C is equal to 1 by n, or rarer medium by denser medium. Rarer medium by denser medium. So rarer medium is how much? Refractive index of rarer medium can be written as 3 into 10 power of 8 by, so 2 into 10 power of 8 into 1.5 into 10 power of 8 by 3 into 10 power 8. 3 into 10 power 8. So this 3 into 10 power of 8 and 3 cancel. This one will cancel. 1.5 can be written as a 3 by 4. Right? Therefore that is a sin C. And I can write this C is equal to sin inverse of 3 by 4. Sin inverse of 3 by 4. Therefore this theta should be greater than sin inverse of 3 by 4. So option 4 is answer. Hope that's clear, right? There was a question number 42. Let's talk about the question number 45. Let's talk about the question number 45, right? So let me take out the question. Let me take out the question number 45. This is the question. A small bulb is placed at the bottom of a tank containing water to a depth of √7 meters. The refractive index of water is 4 by 3. The area of the surface of the water through which light from the bulb can emerge out is x pi meter square. We have to calculate x. Again it's kind of refraction on a plane surface question, right? Let me take it as a interface. Sorry. One second. So let it be the interface and let it be the normal line or no need of normal line. A small bulb is placed at the bottom. So this one is a bulb. A small bulb is placed at the bottom of a tank containing water to a depth of root 7 meters. So the water height is root 7 meters. The water is up to root 7. The refractive index of water is 4/3. The area of the surface of the water through which light from the bulb can emerge out is. So there is a bulb over here. Now this is the interface and the water is up to root 7 meters. Now we have to find out the area of this. Already we explained this concept, right? So let's say the water is coming like this. Or let me change the pen color from here as well as here. And you know that if it is incident at a already like in case if it is incident at a critical angle, that goes to the interface, right? And the light will move through the interface like this. It will move through interface like this, and it will also move through this interface like this. And we have to find this area of this we have to find out area of this circle. We need to calculate area of this circle, this one, right? We need to find out area of that circle, and let's say it's 1 second. Right. Let's say this angle is C. Critical angle incident through interface by the you know this angle also C. And here this refractive index of water is how much? 4/3. This refractive index of this water is 4/3. Therefore he could say the sin C, and you need to find out this radius here. Ikkada radius kanukovali, and you know this height already. This is nothing but how much? The height is root 7 meters. So therefore if you want to find out the arc here, so from the tan C, you could say tan C is equal to R by H. Therefore R is equal to H into tan C. R is equal to H into tan C. So please keep this in our mind. So that formula is important. So R is equal to H into tan C, right? Therefore I can write this R is equal to H is root 7 and tan C. Tan C can be written as, if you want to find out tan C, you have to apply that critical angle formula, right? Therefore from that sin C can be written as sin C is equal to what? Sin C is equal to 1 by n. That is a critical angle that is the angle of critical angle. So therefore I could say the sin C is equal to 1 by, how much is it? 1 by 4/3, nothing but I can do the 3/4. If sin C is a 3/4 from this right angle triangle, you can write this as a 3 here, and you can write as a 4 here. Now this will be how much? This can be like this can be written as a 16 minus 9 is equal to something like x square. This can be written as root 5, right? This can be written as a root 7. This can be written as root 7. So this is how much? Root 7. So that can be written as root 7. So therefore from this I can add the tan C. R is equal to I can add as a H. H is how much? Root 7 into tan C is how much? Tan C can be written as, what is the tan C? Opposite by this adjacent, so which is nothing but a 3 by root 7. Therefore this root 7 cancel. R is equal to 3 meters. Therefore you can find out the area. Area is equal to pi r square. Therefore pi is pi only, and R is how much? R is 3. Therefore I can do the 9. Answer is this will be like 9 into pi meter square, that is the area. Therefore the x value is how much? X value is the 9. Therefore the x value is the 9. Clear? So there are remaining problems. How many? Up to 45, right? What is problem number? It's problem number 45. I completed up to 45. So how many problems are completed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 problems completed, and the remaining problems will be I will upload it by the night, right? Thank you.